So far, we've discussed the center and spread of the normal distribution model, but it also has a height, okay? So that values near the middle, near the center, near the mean, they're more likely to occur than those in the tails. Keep in mind that the normal distribution model is in fact a probability distribution, okay? So the height of the normal distribution model, it's given by a mathematical function that we call a probability density function. The important point is that the height is sometimes called the curve of the probability distribution. And the higher that height, the more likely a certain area under the curve is to occur. Because for a given range of values, the area under the curve, it's the probability that those range of values will occur. And that the total area under the curve equals 1. That's because the normal distribution model, it's a valid sample space. The probability of the entire curve equals 1. So this is what the normal distribution model looks like. The height of this curve tells you how likely a certain set of values are to occur with a given range. And so you can see that around the mean, okay, near the center, those values are more likely to occur. The height is higher on the normal distribution model. The farther you go from the mean, in either the right or the left, the values are less likely to occur. Okay? The important point is that that height of this curve tells you how likely certain values are to occur. And again, as a reminder, we denote this normal distribution model using the notation of, x is distributed as a normal distribution model, and it's centered on a mean, and it's given by a spread, which we call mu and sigma squared. Now you might ask, what happens if we set the mean to 0 and the variance of equal to 1, or the standard deviation equivalently equal to 1? If we have these two values for the mean and the spread, then we have what is called the standard normal distribution model. Sometimes it's called a unit normal distribution model. For short, we usually call this a z. So when we use the notation that z is distributed as a normal distribution model centered on 0 with a variance of 1, or standard deviation of 1. This is a very commonly used version of the standard of the normal distribution model, and we call it a standard normal distribution model. So the standard unit normal distribution model looks the same, but the important point is that the mean is 0 and the variance, and equivalently the standard deviation, is 1. Now the important point is that it is a kind of normal distribution model. It just has these two particular values. So here we have two normal distribution models. They're on the same scale. And you can see that the distribution on the left has a mean of 0 and a variance of 1, while the distribution on the right has a mean of 19 and a variance of 4 squared. So the distribution looks a little bit different. They're both symmetric. They're both mound-shaped. But one has a higher peak because it has a narrower range, it's a narrower spread. You can think of this kind of distribution in terms of z-scores, right? So if you have some variable x, you subtract out the mean and you divide by the standard deviation, right? You have z-scores. So keep in mind the z-score of a value is just the number of standard deviations it falls above or below the mean. So the standard unit normal distribution, you can think of it in terms of z-scores. It's just a bunch of z-scores, right? So for example, if you have a z-score of 1, you're 1 standard deviation of the mean. If you have a z-score of 0, you're right on the mean. If you have a z-score of -3, you're -3 standard deviations below the mean. So it's very useful to think of the normal distribution model in terms of z-scores. Right? That's when we convert any variable to z-scores, okay, and we think of it in terms of the standard normal distribution, that mean is 0, and that variance is 1. So there are a couple things to know. The normal distribution model, we can express it as some variable x being distributed normally, centered on a mean and some variance. We use Greek letters for the normal distribution model by convention. There are many distributions in data sets that are approximately normal, and so we can use the normal distribution model to compare with the actual distribution in these data sets to see, could we just model this distribution in the data using the normal distribution? The height of the normal distribution model tells us how likely certain sets of values or ranges of values are to occur. That's because the normal distribution model is a probability distribution. The total area under the curve is 1, and then we have probabilities for certain values within certain ranges. If we convert some variable x to z-scores, then we have a standard or unit normal distribution in which the mean is 0 and the variance is 1. And with that, we've concluded our discussion of the normal distribution model and the standard normal distribution model.